Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel with practice problems for actuarial exams is at smarturl.it/pass actuarial exams. Here you have links to information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for today for exam FM on financial mathematics. A company has liabilities of 573 due at the end of year 2 and 701 due at the end of year 5. A portfolio comprises two zero-coupon bonds, Bond A and Bond B. Determine which portfolio produces a Reddington immunization of the liabilities using an annual effective interest rate of 7%. Answer A has Bond A, which has 1 year maturity and current price of 500. Bond B, 6 years, zero coupon bond, current price 500. In answer B, Bond A, 1 year, current price 572. Bond B, 6 years, current price 428. In answer C, Bond A, 3 years, current price 182. Bond B, 4 years, current price 1092. In answer D, Bond A, 3 years, current price 637. Bond B, 4 years, current price 637. And answer E, Bond A, 3.5 years, current price 1000. Bond B is not used. And here's the solution. So in order for the asset portfolio to immunize the asset liability combination against interest rate risk, assets must have the same present value and Macaulay duration. We could also work with duration, but this would make calculations slightly more complicated. Macaulay duration is generally easier because it's the weighted average time till maturity of the cash flows, and that's usually a very simple calculation. And greater Macaulay convexity than the liabilities. Again, you could work with convexity, but Macaulay convexity is more convenient. For example, for a single payment, the Macaulay convexity is just the square of time till the payment. The present value of the liabilities is 573 over 1.07 squared plus 701 over 1.07 to the fifth. That's approximately 1000.2837. Well, we more or less take it to be almost exactly 1000. The Macaulay duration of the liabilities is 573 over 1.07 squared times 2, the time of payment, plus 701 over 1.07 to the fifth times 5, the time of payment. All of this divided by the price, the current present value of the liabilities. This is basically the weighted average time until cash flows. And that comes out to be approximately 3.49898457, and it's almost exactly 3.5. Finally, the Macaulay convexity of the liabilities is, well, the weighted average time until time squared, the weighted average square of time until the payments are made. In this case, payments are made at times 2 and 5. So this is 573 over 1.07 squared times 2 squared, plus 701 over 1.07 to the fifth times 5 squared, and the whole thing divided by the price. So that really the weight of 2 squared is 573 divided by 1.07 squared divided by the price. And the weight of 5 squared is 701 divided by 1.07 to the fifth, and the whole thing divided by the price. This comes out to be approximately 14.4928927, approximately 14.5. So now, as we know the parameters, the present value, Macaulay duration, and Macaulay convexity of the liabilities, we compare that to the answer choices that we have. For answer choice A, the present value is 1,000. It's two bonds, each with a value of 500, so the total is 1,000. And the Macaulay duration is 500 over 1,000 times 1 plus 500 over 1,000 times 6, because the times when the cash flows paid are 1 and 6. And this is 3.5. While the Macaulay convexity is 500 over 1,000 times 1 squared plus 500 over 1,000 times 6 squared, and that comes out to be 18.5. Thus, portfolio in answer choice A has, within a small margin of error, same present value as the liabilities, same Macaulay duration, and greater Macaulay convexity than the liabilities, and appears to do the job, and A appears to be the answer choice. We'll look at the other answers to eliminate them now. Answer choice B, portfolio, has the present value of 1,000. That's good. But its Macaulay duration is 572 over 1,000 times 1 plus 428 over 1,000 times 6, and that's 3.14, and it's less than 3.5, which is needed to immunize the liabilities. And portfolio and answer choice B does not work. Portfolio and answer choice C has greater present value than 1,000. Portfolio and answer choice D also has greater present value than 1,000. Portfolio and answer choice E has the present value of 1,000 and Macaulay duration of 3.5, as it is a single payment at time 3.5, but its Macaulay convexity is 3.5 squared, which is 12.25, which is less than the Macaulay convexity of the liabilities, and therefore portfolio in answer choice E does not provide immunization because its convexity is too small. So the answer choice is A. Please remember, this is copyrighted material. The problem itself comes from the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.